Welcome to the Daily Recall Show. I'm your host, Vasily, and today I will cover not just one, but four specific tools for problem solving. Okay? So, in the past couple episodes, we've talked the ideal state law, the multifunctional form, and all those principles that systems evolve upon, right? But how to actually use those principles to solve specific problems that just lie around everywhere. And that's what we're going to focus on today. And the first idea, I will start from a couple examples, but basically the first idea is that you can solve a problem and you can kind of takes this system through different steps of its evolution by what I call the monopoly approach, by doing the monopoly transformation. What does that mean? Monopoly is basically just a mnemonic, a useful kind of metaphor for visualizing this, okay, and for remembering this. I'm sure you probably have played the game, but yeah, basically monopoly transformation says that it's very useful to solve problems by just transforming the system from performing single function to performing many functions, okay? So an example of that would be that a monosystem is a pin, right? A clerical pin, like this thing with a spearhead. And it's a monosystem, it performs its specific function, and we can transform this pin into a bi-system by just doubling the number of spearheads, okay? And whenever we do that, we're not just like creating like two pins and inserting them together, that might work as well, but if we do arm those two spearheads on one pin, that would make it actually much more efficient because their piece of paper that you pin to the wall with this pin would not kind of slide, right? So that's just one example. Another example of monopoly transformation would be the nail, okay? So I'm sure you've seen one. It's like a thing that you use to connect a couple pieces of wood together, right? So Finnish guys actually come up with it's called the Finnish nail, and it's basically like 200 nails, okay? It's a metal plate with 200 nails on it that stick from the plate. And the cool thing is that all those nails, they share one top, right? So they all connected to this one metal plate. And whenever you connect something with this plate, it's actually 2x efficient. So it's doubling the efficiency, instead of if you use just like 200 nails put together. Okay, so those are a couple examples. Another one would be the anchor example. So when the sailing industry just started, the anchor actually originally had just one hook, right? So the anchor is the thing that you throw into the water so that you stay in the same place. And it had just one hook, but then they thought, okay, but if we double the number of hooks, if we transform the system from mono state to bi system, right, where bi means for doubling, then it's basically better because two hooks are kind of drill down the soil better, and therefore they keep the ship in the same place. And modern anchors, they actually have many hooks and they look like these things, right? So it's a poly system where you take that initial system and you transform it through mono or to bi and then to poly system. Okay, so a poly system is basically many mono systems connected together. But the cool thing that happens when you do this monopoly transformation is that you're not just putting a bunch of elements together. When you do this, it's actually creating, as a byproduct of it, what emerges is a new internal environment. And internal environment means that those things, when put together, they like new qualities emerge from that, okay? And those new qualities are actually really useful because they add up new functions and new capabilities to the system. An example of that would be what is called the US glass production story. So there was a glass manufacturing in the US, and whenever you manufacture glass, especially like big pieces of glass, you need to polish the sides. And it was really hard to polish each piece of glass individually because it's very fragile. If it's like really, really thin glass, it's very fragile and you just break it, okay? But what they did is that they put a bunch of those pieces together, transformed from mono to polysystem state, okay? And they actually like connected them with some glue. So this glue combined with those many pieces of glass put together basically created a block of glass. And that block could be easily transported because the surface of each side of the block is much larger than the surface of individual piece of thin glass. And that's how they were able to polish it very efficiently. And then they came up with a glue that kind of disconnected the pieces after some time or when put in reaction with water. And that's basically it. That's how they solved the problem. So if you had just one piece of glass with the glue, that wouldn't work, right? So by connecting these pieces together and by adding some additional elements like glue, they were able to create a new internal environment. So that's just the one-on-one on how systems transform through these stages, from being a monosystem to a bisystem where two monosystems are combined together, and then to a polysystem where many monosystems are combined together and a new internal environment emerges which adds new capabilities and new functions. Great. So now I'm going to walk you through a specific example of how we would use this transformation and what are the four techniques that we can use to think through this transformation and to actually solve problems by knowing this principle. And the object, that's the system that we're going to use, it's actually a very simple one. It's called a pencil, okay? And I actually don't have one nearby, but just imagine like a single pencil or a black one, right? So it's a monosystem. It has one function. You can draw with this thing. You can probably do other things, but it's just a monosystem because it performs this singular function, okay? And we can transform this monosystem into a polysystem using the first law of transformation, which is we just combine these many individual monosystems together. Okay, so that's basically it's called a homogeneous transformation because those all are similar and therefore we just combine them together. But even this combination, transforming it from a mono to a poly state, creates new functions. So that's one. And as a result of this, we've got our homogeneous polysystem. It's basically a pack of pencils. Okay, so that's great because a pack does much more, because whenever you have a pack of pencil, you can actually draw together, right? You can share a pencil with a friend and you can draw together, so that adds up some communication function, some collaboration functions, stuff like that. And you don't run out of it that easily, and if it breaks, it's actually good because you have another one nearby. So that's the first step. And again, the first step of mono to poly transformation, the monopoly transformation, that's an easy way for you to remember it, is to transform the system, the monosystem, from being just one system, the monostate, to a homogeneous polysystem where there are many monosystems combined together. Okay, so that's one. The second one is called shifting parameters. So what does that mean? We take this pack of pencils and then we think, okay, and can we shift their individual parameters of each of this pencil so that the whole system becomes better, right? And an easy solution, you might have probably guessed it already, would be to transform them from being just one color into a multicolor pack of pencil. So that's how, by shifting parameters, the parameter of individual pencil here is color, right? So by shifting parameters, we've got a pack of multicolored pencil. So that's basically the second stage, which is shifting parameters, and that's how we got from their homogeneous polysystem, just a pack of black pencil, to a pack of multicolored pencil, which is a homogeneous polysystem with shifted parameters, right? That's the first two steps. And the first two steps, they actually combine into one group, which is our monofunctional steps. So those steps, they do not alter the functions of the system, of the poly system, because you can still just draw with this thing, right? That's it. You cannot do anything much, even though it's a pack and even though they're multicolor. But then the third step would be to transform this homogeneous poly system with shifted parameters into a heterogeneous poly system with shifted parameters. What does that mean? That means that we take this system of pack of multicolor pencil and we then think, okay, but they actually do some function, right? They perform some function, and the function is probably like drawing. But can we add another object to the system, to the pack, so that we augment the function, not just the function of individual pencil, which is to draw a line or a circle or whatever, but the function of the super function, which is drawing some piece of artwork, right? And if we think through the aided design perspective or through engineering perspective, an obvious solution would be to add a compass to the pack. And that's why you see these packs being sold everywhere with rulers and compasses, right? So that's next time you see that, you can say that this is a heterogeneous poly system with shifted parameters, and you can look smart. So that's basically it. That's what it is, right? Whenever we add a new object to this poly system, it becomes heterogeneous because it does not anymore have our objects of one type, which is a pencil. It has objects now of two types. And then you can go on forever, right? You can transform this as much as you want. But then the last step, the fourth step of system transformation would be to invert the characteristics of a system. Okay, so if the function that we originally performed was to create a line, an inverse function would be to erase a line. So by taking this step 3 to step 4, we would add an eraser to the pack of multicolor pencil with compass. And that's how we can perform the anti-function instead, right? So before, the system did not allow any kind of sort of erasing, and now it allows the thesis, the object, the function, which is drawing, and it also allows the anti-thesis, the anti-object, which is erasing. So that's great. That's how we basically took a simple mono system of a pen, a pencil, through these 4 steps of transformation, and we reached our poly system with heterogeneous objects, with shifted parameters, and finally with inverted parameters. So that's how you do that. That's how you apply this transformation. And again, just to recap, the mono system transforms into a poly system originally through this evolution, and the 4 ways to do this transformation is first the first one is to combine a bunch of monosystems together so that the new internal environment emerges and the new qualities emerge. The second state is to shift the parameters of individual monosystems. The third one would be to transform them from being those monosystems from being homogeneous of one type to heterogeneous of many types. And the fourth one is to invert the function. And that is how you can go from having one pencil into having multicolor pack of pencil with compass and eraser. So that's a much more useful tool for drawing. Thanks guys for watching, and see you in the next episode.